In this problem, the statement is for a brass alloy, the following engineering stresses produce the corresponding plastic engineering strains prior to necking. So these two are the plastic engineering strains. I mean, these two are engineering strains, but they are in the plastic condition. Okay. And on the basis of this information, compute the engineering stresses necessary to produce an engineering strain of 0.25. Okay, remember that here in this case we have to estimate the stress which is in between these two values. But the condition is that these strains are in the plastic condition. Okay, so if they are in the plastic condition, then you cannot apply the Hooke's law. So Hooke's law cannot apply. Okay, so then what we can apply? So we know that for the plastics condition, we have this equation. Sigma true stress is equal to K times true strain power n. Okay, so this equation uses the plastic stress, the true stress and true strain. Okay, but we have been given as the engineering stresses, but we also know that we can find the true stress by the engineering stress by this equation. So if I apply this equation, I can find the engineering stress. Okay, and then I can find the engineering strain as well, sorry, the true strain as well by this equation. Okay, so let's convert these engineering stress and engineering strain into the true stress and true strain. So okay, so if it is 235, this value, then it will be equal to so this is not the true strain. Okay, my mistake. So I need to find the true stress, and 235 into 1 plus the engineering strain. Engineering strain is 0.194. So this will give a true strain, a true stress of equal to 280.6 megapascal. And similarly, the other value for the true stress, so let's say it as sigma T1. Okay, and then say sigma T2. So the other value will be 250 times 1.296. So it will be equal to 324 megapascal. So now I have determined this true stress and true strain. So I can also determine the true strains as well for these two conditions. So sigma T1 will be equal to log of 1 plus E. It will be equal to 1.194. So this should be equal to 0.177 after calculation, and sigma T2 will be equal to log of 1.296, that is equal to then 0.2592. So these are the true strains. Okay, so from these two values, what I can do is, now we need to find the necessary to produce the engineering strain of 0.25. So why did I found these values? Because we don't know the K and N. So from these two conditions I can find the values of either K or N. So now I apply this equation. Okay, so I take this value of 280.6 equal to K, we don't know K, but epsilon T corresponding to this was 0.177, then power N, and then for the second one it is 324 equal to K into 0.2592 power N. So what we can do is I can divide this equation, the first equation, by the second equation, and then simplify it, and then I can determine the value of N, which will be equal to 0.377. So now I can use this value of 0.377 for later calculations. So there is this third strain, which is the engineering strain, which is given. So the third true strain will be equal to log of 1.25. So this will be equal to 0.2231. So now I can use this value, and I still don't know the value of K. So what I can do is I can take any of this equation. So for example, I take this equation, okay, and apply the third equation. So for the third equation I need to know find the value of sigma T3, which is equal to K, and its corresponding strain is 0.2231, which I have just determined. So 0.2231, and power N, now I already know power of N, and then I can take this equation, okay, and I have this equation. So this equation over here. So if I divide this equation by this equation, so it will be divided by 324 equal to divide. So there is no equal sign over here. So that will be equal divided by K, it will to 0.2592 power 0.377. So K will cancel with K, so the only unknown is sigma T3. So sigma T3 in this case will be equal to 306 megapascal. And what has been asked is engineering stress necessary. So we need to convert this true stress into the engineering stress. So I can use this equation. Okay, so for this I need the engineering strain, which is 0.25. So let's do it here. 306, which is the true stress, equal to the engineering strain, which I need to find, sigma 3. Let's say it's sigma 3. Okay, and it is 1 plus the engineering strain was 0.25. So in this case the final answer will be equal to 245, because when 306 when divided by 1.25, it will be 245 megapascal. So the engineering strain will be 245 megapascal.